Here is the next example. In this example, he's asking for find the transfer function, closed loop transfer function for the following system. So far, in all the previous examples, we always have, the input R on the left hand side, output C on the right hand side. Okay, or output I call it as Y, input is U. Okay, and R or U as input, or C or Y as an output. Now what I'm going to do, I'm going to redraw this diagram according to this. So there are three summing points, 1, 2, 3. So I'm going to go in this direction. So from R, reach the first summing point, then go to Z3, then second summing point, and then second summing point to Z8, through Z8, Z5, Z2, Z1, and reach C. Okay. Now at the third summing point, G7 is taking off at before Z5, and it is reaching the third summing point. At the same time, G6 is taking off at third summing point, reaching second summing point. Okay, and the signs are given. Now, we never this before in the previous examples. In this example, what I'm going to do, we can able to move a block we're able to move a block in front of a summing point to the other side of the summing point. So we can it is easy for us to move a block in front of a summing point to the other side of the summing point. So that's what I'm going to do here. But remember, the output signal must be the same. Say for example, here A is the output signal, B is the output signal out of these two. Now what is my output signal after G6? It must be G6 times A plus G6 times B. Okay, that's what I have it here. Now even after moving this G6 to the other side, I should end up with the same signal. So what should I do? When I move this G6 to the other side, I have to multiply A. So G6 must go right here, and G6 must go right here. Okay, so basically when you're moving a block from in front of summing point to the before summing point, you have to have the block for all the inputs coming to that summing point. So that's what I did here. So G6 is moved back here, G6 also moved back here. Now you can see I'm getting A times G6 and here A times G6, B times G6. So these two are parallel, so we can add them. Now another thing I can do here, what I'm going to do, I'm going to move the takeoff point of this after G1. So takeoff point of this G4 and G6, I'm going to move this takeoff point from here to, this is just before G1, I'm going to move it to the after G1. Okay, so when I move this after G1, so whenever you're moving a takeoff point in front of the block to the after the block, you need to divide that feedback by that block. So that's what I did. So here, if you look at here, G6 and G4 in series, so multiply them. So G6 G4 divided by G1 when I move it after to the block. Okay, and same thing here, I moved this takeoff point, G6 G7 takeoff point to after G1, so I have to divide this G6 G7 divided by all these three blocks. So that's what I did here. Okay, now you can see these two are in parallel. When they're in parallel, I can add them, and both have same sign, so I can easily add them. So when I add them, it's G4 G6 over G1 plus G6 G7 over G1 G2 G5. Okay, so G1 is a common on both sides, so it's going to be G1 G2 G5. So here it's going to be G4 G6 G2 G5 plus G1 G6 G7. oh sorry, g1 is already in there, so you don't need to have g1 there. Sorry, g6 g7. So the answer is going to be, this is what we're going to have. Okay, at the same time, g8 g5 g2 g1, these are all in series. I can combine them, end up with g1 g2 g5 g8. Now instead of feedbacks, instead of having f or h, he's using g. It doesn't matter. Okay, now we know that if you have a system, a feedback system like this, okay, with the negative feedback here, what is your answer? Y over u equal to x over 1 plus, if you have minus here, you have to have the plus there, 1 plus f times x. That's your transfer function. So I'm going to do the same thing here. So my x is g1 z2 z5 z8 and y is all this thing. So I'm going to use the same principle and find that transfer function. So I end up with g1 g5, sorry, g1 g2 g5 g8 divided by 1 plus, since I have minus there, it's going to be plus g1 g2 g5 g8 and all these things. So here you can clearly see these get cancelled out. Okay, once I cancel out, I have only g8 left. So if I take to the g8 inside, I have g8 in both terms. Now these two are in series, you can multiply them. So all you need to do is g1 g2 z3 z5 g8 divided by that. Now it has a unity feedback with a negative sign, so you will end up with plus there. So it's going to be y over e equal to x. If I take this whole thing, I mean multiplied with z3, this whole thing as an x, it's going to be x over, since I have minus there, it must be plus here, 1 plus x. So I use the same principle, end up finding this transfer function. Okay, thank you. I'll solve a couple of more examples in the next video.